these are the notes on scientific notation. Scientific notation is a way to express really big or really small numbers without having to write a ton of zeros. So if I'm thinking about having a really big number, maybe I've got something like this. That's a really big number. That's 764 billion. Now, writing all these zeros is not only a pain and really annoying, but it also leaves for a lot of easy mistakes. So it's really easy to make mistakes on this. And so that's why we use scientific notation, because you're less likely to make a mistake when you don't have to write out all those zeros. So that's the idea here. For really big or really small numbers, you use it a lot in science. You're talking about stuff like amoebas that are really small, or distance to the moon that's really big. So let's look at this first one. The speed of light is 1.8 times 10 to the 10th meters every minute. So that's really fast, right? That's a huge number. So when you see scientific notation, you're always going to see one number before the decimal point, and it's always going to be times 10 to an exponent. That's just the way it's written. It's always times 10. So the first thing I want to look at that's really important is the exponent. The exponent tells you how many times to move the decimal point. So I'm going to highlight this exponent. That's how many times I move the decimal point. I'm going to move the decimal point 10 times. Let's put a note there. Move decimal point 10 times. That's what that means. Move it 10 times. So I'm literally picking up the decimal and moving it. The other thing here is if the exponent is positive, I'm going to move the decimal to the right. That just makes sense. When you count on a number line, positives are to the right. So this is moving to the right. So I'm going to move 10 spots to the right. So I'm literally going to take this decimal and I'm going to bump it 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Bump it 10 times. Now I'm going to fill in all these spaces with zeros. And now this is where the decimal ends up. I moved it to the right, and it ends up all the way at the end. So the last thing I need to do is rewrite this. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. Commas go every 3 from the right. 1, 2, 3, 1, 2, 3, 1, 2, 3. So this is my final answer, and if you want to, you can put the decimal point all the way at the end. Anytime we've got a positive here, the decimal is always going to end up at the end of the number, behind the last digit. So we literally moved this decimal 10 times to the right. So let's do some practice here. Bump this up a little bit. There we go. Alright, 9.2 times 10 to the 6th. So here's my exponent. It says I'm moving 6 times. It's positive, so I know I'm going to the right. So I'm going to rewrite this number, 9.02. And I'm going to move it. 1, 2, 3, 4, 5, 6. Now I need to rewrite it. Comma, comma. And the biggest mistake that students make here is they rewrite this number and they just do this. Oops, there's a 0 there. And they still have the decimal here. And they say, well, I added my zeros, but you didn't actually move the decimal. Adding the zeros moves the decimal, so the decimal's all the way over there. The number can only have one decimal, so you have to rewrite it to not have that extra decimal. All right? Let's look at the next one. The next one is to the 4th power. That means I'm going to move it 4 times. When I have a whole number, the decimal just starts at the end. So I'm going to take this decimal and move it. 1, 2, 3, 4. Okay? 90,000. And again, the decimal of this number would be here. If those jumps are hard for you to do, another way you can do it. You could do lines. 1, 2, 3, 4. And then I would put in my zeros. It works the same way. Some people like to do jumps, some people like to do lines. So either way is going to get me that answer. Let's look at these last two. There we go. All right, 2.305 times 10 to the 8th. So 8 times to the right. 1, 2, 3, 4, 5, 6, 7, 8. Do the rewrite. Comma, comma. Okay, the decimal's right there. This last one, second power here. Decimal starts at the end. This is 400. Okay, so I just moved the decimal point. I moved it. I'm not adding 2 zeros, because look at this one. I didn't add 8 zeros. This one I only ended up adding 5 zeros, even though the power was 8. It's how many times you move the decimal, not how many zeros you add. Let's look at the back. Flip over here, bring us up. Alright, so same idea here. It takes light, time it takes light to travel 1 meter is 3.3 times 10 to the negative 9th seconds. So again, my exponent is going to tell me how many times to move that decimal point. So there's my negative 9. The other thing that's important here is if the exponent is negative, I'm now going to move to the left. So if you think about getting more negative on the number line, you're always going to the left. So I'm going to take this decimal and I'm going to move it 9 times to the left. 3, 4, 5, 6, 7, 8, 9. Had some zeros. And my decimal point's over here. So here I moved it 9 spaces. 3, 4, 5, 6, 7, 8, 9. 9 spaces to the left. So my new number here is and again, I don't have a decimal over here anymore. I picked it up and I put it all the way over here. So when you're doing small numbers, your decimal is going to end up all the way on the left. All the way on the left. Remember, this number is the exact same thing as this number. Having that 0 before the decimal point doesn't change the number. It's the same thing. So let's look at the next one. Alright, so I've got 2.04 times 10 to the negative 5th. That negative 5 tells me I'm moving 5 times to the left. So 2.04, 1, 2, 3, 4, 5. And now my decimal's over here. There it is. Let's look at the next one. To the negative 3rd power, so 3 times to the left. With a whole number, my decimal starts at the end. 3 times to the left. 1, 2, 3. Okay, let's look at the last two. Just highlighting my exponents there. So negative 6, 6 to the left. 4, 5, 6. Okay, this one's moving 2 times to the left. 5.3, 1, 2. So remember, we're moving the decimal that many times. Again, on this one, 1, 2, 3, 4, 5 zeros were added, but the exponent was 6. It's not how many zeros we add, it's how many times I move the decimal point. So these are the notes on scientific notation, putting it into standard form.